Hello and welcome to this evening office hour. Experimenting with some new times since I know a lot of folks are not always available earlier in the day, the traditional 9 to 5 workday, as it is for many folks. And so I am going to try and do at least some occasional evening sessions. I have done these previously during episodic extreme weather events when conditions warrant late into the evening. Today, this is just a regularly scheduled event. Because there is no extreme weather today in California, although there is still some interesting and notable weather. I wouldn't call it extreme by any means. In fact, it's somewhat notable for its lack of extreme conditions in many cases right now, with a couple of minor exceptions. But I think that's something that folks in different parts of the state are willing to see that as the trade-off, because it's been quite a summer, depending on where you are and depending on which part of summer you're talking about. Of course, summer 2024 ended up being the warmest on record, really tied for the warmest on record on a statewide basis. But that was mainly because of truly record-breaking heat across the northern, eastern, and interior parts of the state back in July, especially. And then that's been followed by a cooler period. But not to be forgotten, Southern California just in the first half of September experienced its own episode of record-breaking heat that was followed by a pretty dramatic sequence of thunderstorms, fast-spreading wildfires, some of which are still burning and some folks are still evacuated today. Talk about that, a fire update. It is mostly good news relative to the last time we spoke, and the other update is the pair of low pressure systems in California this week. One is currently overhead and has brought some showers to certain parts of California over the past 24 hours, and a secondary low, which now looks like it's going to take a slightly more westerly or over water trajectory and maybe bring a slightly higher chance of showers to some spots along the coast than was initially believed when I wrote my last blog post over the weekend, for example. So I'll talk about that as well. Just want to remind folks that this channel is partially sponsored by Reask, a climate tech company that is helping organizations quantify and manage extreme weather risk in a warming world. So, as I mentioned, the pattern is quite different in California and the West than it has been, and it's pretty dramatically illustrated, even though the pattern itself is not super dramatic, by a rather picturesque low-pressure system currently spinning over the state. I'll show some satellite imagery in just a moment. But just wanted to emphasize that although the three major fires in Southern California remain active, that is a relative term, and two of the three are more active than others. So the airport fire in Orange County is mostly inactive at this point. It's the line and the bridge fires that remain somewhat active, but the level of activity is many times reduced from what it was at the peak. These are no longer fast-spreading fires, although there are still active portions of the fire line, and there are still tens of thousands of people still under evacuation orders in Southern California. They have been reduced, and some of those orders have been downgraded to warnings, and that's a trend I would expect to continue. And I'll show some of those maps too in a moment. So I think it actually might make sense to start out by showing some of the satellite imagery. So bear with me for a moment while I share my screen. You'll see the brief infinite mirror before I go over, and you should be seeing right now a nice swirling region of low pressure over California. As always, I just want to double check that's actually what you're seeing. Looks like it is. Okay. So I'll bring up my drawing tool because there's a couple of interesting little features. Again, nothing especially dramatic, but definitely sort of a fascinating picture here. And here we go. Let me get this to linger on screen. So the low is somewhere over here right now. So we're seeing that circulation around the low pressure system like this, cyclonic flow. A few interesting features of note would be There are some scattered showers and even some isolated thunderstorms over up in the Sierra Nevada. More showers and storms out over the Great Basin in Utah, and even some over Arizona, so this is a fairly active fall pattern. The clouds towards coastal California are a lot shallower, so these are just stratocumulus clouds, so this is just I guess I'll call it a glorified marine layer. There are a couple of isolated clouds that may be barely tall enough to produce a brief sprinkle or shower down here, and then a couple of scattered showers up here. No lightning to speak of, although yesterday there was a cluster of pretty strong thunderstorms up in the northern Sacramento Valley. Up here, none of that today. The atmosphere is more stable, but that resulted in some fairly dramatic lightning and downpours up by Redding, Red Bluff, and up by Mount Shasta, where some more significant precipitation accumulated. All in all, this system produced very little precipitation in this part of California, which is, of course, where most of the people in California live. The next system, though, might produce a little bit more, or at least a chance of slightly more widespread precipitation in places like the Bay Area and in coastal Southern California that really didn't see much of anything with this one, which is consistent with expectations. Probably worth zooming in a little bit, since there's some cool features on the satellite in Southern California. One thing I will note is the absence of smoke. So although there are still some hot spots right now on the fires, there's no big smoke plume, so in this vicinity where the fires are, or down here, so that is an indication that the fires are a lot less active, much less active than they were. But the interesting little features, and again, these are so weak they're not even producing showers, so there's not even any precipitation. We'll call them fair weather cumulus convergence lines. Take a look at this one. I'm going to draw a few different lines, interesting little features, in very different parts of Southern California right now. These are all what I believe are convergence lines in the atmosphere, where there are essentially a sea breeze that's converging with some other wind flow that's moving in a slightly different direction to produce just enough lift in the atmosphere to result in a few isolated fair weather cumulus clouds, but along these very well-defined little axes here. So essentially what you have are winds that are converging towards the center line from the sides near the surface, resulting in upward motion in the atmosphere, because you can't, nature abhors a vacuum, I guess is the short version, but if you have winds converging from the side, instead of air accumulating, it wants to diverge away from the surface, and of course because the breeze can't go underground, you're forcing air upward. So to maintain conservation of mass, the air's got to go somewhere, and so it goes up. So I think that's a neat little example here of almost entirely inconsequential weather that you can actually see live from space. Looks like this line extends from about Long Beach into the either the San Fernando Valley, or maybe I guess that's more the Inland Empire, really, as you go that far east. This one is out Antelope Valley, and this one up, I guess, on the coastal plain up by Oxnard. So just some interesting sea breeze convergence going on. You can see, of course, the clouds over the mountains. It is interesting on days like this that you can really see the influence of topography on clouds. Look how these shallow cumulus clouds are really hugging the regions of high topography in Southern California. So this pretty much is an outline of all the most mountainous parts of Southern California. And again, the isolated exceptions, these little mini sea breeze fronts, are kind of cool. So I just thought folks might enjoy this imagery because it's kind of an interesting feature. Oh, and the other cool thing, I actually just noticed this now, take a look at these little cloud streets. So these linear cloud features emanating on the leeward side of the islands. So the surface winds are blowing like this, and these clouds are forming. So let me, this is actually a little bit unusual, so kind of cool. Again, not consequential. You can see that these are just lines of fair weather cumulus clouds. But what's happening as the wind hits these islands, and again, the Santa Catalina Islands and San Clemente Island, they have some significant topography. So there are mountains hundreds or even a couple thousand feet tall. And so as these surface winds approach the island, again, because of conservation of mass, they can't go through the mountains on the island, so they got to go around. And so the wind does this around the island and converges right around here, and it does so in a line like this, and that is what produces these sorts of linear cloud features down under the island. It's kind of cool, and you can see the same thing happening roughly along this axis. So as I mentioned, one of these days where there's actually quite interesting tidbits of local meteorology going on, even though there's absolutely nothing dramatic or dangerous or alarming or really even all that notable if you couldn't see the satellite image. If you were just on the ground, that would be a very small little cumulus cloud, but it's quite cool nonetheless. Okay, that's probably enough time spent geeking out on fair weather cumulus clouds. But I'll share the radar really quick just to show you what I mean. Again, there are some scattered showers, no lightning, nothing, no big deal. Just some nice autumn precipitation up from Northern Lake up into the counties to the north. This precipitation is, I don't even think it's reaching the ground, it's just virga, but it did rain up there earlier. As I mentioned, there are a few isolated scattered showers over the mountains, not much, if any, lightning there. Nothing going on in the Bay Area right now, and nothing in Southern California. So that's just about the only radar view that's worth seeing right now. And again, if I zoom out to the broader west, it's pretty active overall. In fact, there's actually quite a lot of thunderstorm activity across the interior west, but California is sort of on the fringe of this. I want to quickly check the comments coming in here. Okay, so I want to show some the watch duty maps of the three major fires in Southern California to demonstrate a few things. One is that evacuation orders are still in effect, so these are all the red straight-lined outlined regions, and the evacuation warnings, the lesser version in orange. There's a few things I want to note. One is that they are still quite extensive in all of the places outlined here. So there are still a lot of folks who potentially can't go back home, which I think is an impact of wildfires we don't talk about as much, are prolonged evacuations, even if your house is just fine and even if the fire activity has greatly decreased. But the other piece is that they are smaller in scope than they were before. So notice that in the Inland Empire, no more evacuation orders or warnings of any kind up along the fringe of the mountains. There were significant evacuations in this region previously. Those are done. I mentioned those might be lifted the soonest, given that's where the best control lines were on the fire, and that's indeed what happened. But there are still evacuation warnings for the Big Bear area, for the Angeles Crest Highway area, and then some more warnings up by Running Springs. But if I zoom in a little bit, what I want to show you is mostly good news. So I have the satellite hotspot layer enabled right now, and what you can see is that, well, there's actually not much to see on the airport fire. There's no recent hotspots. This fire is not completely out cold, but I think this one is pretty much done. I would be pretty surprised if this thing flared back up. If we had a big offshore wind event coming tomorrow, I wouldn't be nearly so confident in that, but given that the forecast for this week calls for potential drizzle or isolated showers and high humidity, much lower than average temperatures, I think this one is done. So still some evacuation orders in effect. This is partly because there was a significant, a triple-digit number of structures lost in this flank of the fire, unfortunately. So part of those evacuations may be to deal with the aftermath of that in those neighborhoods. Go over to the line fire, where there are still some hot spots on one flank of the fire only. That's in the on the northeastern flank, the one closest to Big Bear. So there is, and this fire did get a little bit feisty again yesterday up in this region, but ultimately it's a lot easier to handle a fire that's only active on this one front, even though it's getting close to Big Bear, it allows fire crews to focus on this part of the fire. And again, favorable weather conditions, potentially even some light precipitation, really help tamp things down. So I think that a lot of the remaining evacuation orders, particularly on the northwestern side of the fire by Running Springs, those might not last much longer. They might stay a little bit longer in Big Bear, given that this is the one place where the fire remains active, but they might be dropped sooner than later for the eastern half. That would be my informal prediction. And then over on the bridge fire, which is right around 54,000 acres, there is actually more activity still, and as you can see, more of the evacuation orders remain in effect here. There are several different pockets of continued activity on the fire on different flanks. So, and again, this is the one that is perhaps, well, it is the largest of the three fires and the most remote, and did cover the most ground the most quickly. So you can kind of tell the axis of spread was very quickly upslope like this. And Wrightwood is up in this region where there was structure loss on the west side of Wrightwood, right around here. But we're lucky that it was limited to 0 loss in the center and the eastern parts of town there. So this fire remains active. There are still some hot spots, but again, it's way less active than it was. And I think this one will also benefit greatly from the weather conditions expected the rest of this week. Okay, let's see here. So, take a glance at some comments here. I'll come back to those in a moment. The last thing I wanted to show graphically here would be the current weather model outlook for the rest of the week, which is kind of interesting. What we've got is, and this is the most recent European model run. So this is not the ensemble, because sometimes I like to show the models themselves when we're only a day or two out, because the ensemble, the full distribution of plausible predicted futures that come from perturbing the very same weather model by different initial conditions, is almost always your best bet at longer lead times when uncertainties increase in our chaotic, in the mathematical sense, atmosphere. Makes it difficult to make specific weather predictions more than a few days in advance, but we're still able to look at general patterns up to 7 and 10 days out, and if we squint a bit, longer than that. But on really short time scales, just a couple days in the future, sometimes we can look to the individual models as a pretty good indication of what's going to happen. So that's what I'm doing now here with the European model. This is a little bit back in time. This is early this morning when there were indeed some scattered showers over the Bay Area. Not much over Southern California. That ended up being a little bit overblown. This is what the model thinks it looks like right now, which looks about right based on that radar tour. Just a few light showers over the mountains, fading away, going away. Into tomorrow. Tuesday looks like it's going to be a completely dry day across the whole state, but Wednesday may not be, and this low pressure system, as you can see, actually slides now a little bit off the coast, so west of the coast, meaning that there might be a little bit more moisture. This could actually bring some decent showers to portions of the coastal Bay Area on Wednesday, so morning through early afternoon especially. Once again into the central and northern Sierra, maybe into the Central Valley as well, so some scattered showers. It's going to be patchy, so many places might stay completely dry, but if you're lucky or unlucky to spend, depending on whether you're an almond grower or not, you might be 10-20% chance of a downpour, but a good 70 or 80% chance you remain completely dry. So kind of an all or nothing scenario there with those isolated, widely scattered downpours. Many folks will stay dry. Some folks will say, did you see that incredible downpour a few minutes ago? Down the road, somebody will say, I don't know what you're talking about. It's that kind of pattern, popcorn showers, as they're sometimes called. This low will move down into Southern California on Thursday. Again, doesn't look super dramatic, but as it stalls out a little bit over the central coast as it moves inland, this could produce some scattered showers, maybe an isolated thunderstorm across the southern San Joaquin Valley, the southern Sierra, and also parts of Southern California, mainly in the mountains. Slight chance of some showers along the coast as well before moving inland. And that is probably all she wrote. By Thursday, everything, by late Wednesday in Northern California and late Thursday in Southern California, the pattern looks then dry for the foreseeable future, probably into October. So what kind of precipitation are we looking at? Well, if I take the ensemble average, bring it out, we're talking about and again, some of this precipitation has already fallen today. So this is the sum total of what happened today plus what's going to happen on Wednesday and Thursday. Highest totals in the Sierra, where there could be a decent soaking up to a ½ inch or so in some spots. So that's good news up there. Nice autumn pattern. Mostly just isolated to scattered showers in the Central Valley. So maybe up to locally, most places will stay under a tenth, and a lot of places will stay completely dry. 1 or 2 sites might get a tenth or 2 if they're under a downpour. The Bay Area might see a little bit more on Wednesday, so there could be some scattered decent showers in the Bay Area, maybe even a downpour or 2 or an isolated thunderstorm, and that could extend down the Central Coast into the mountains of Southern California. So this is not a big rain event by any means, but people do have justifiable reason to get a little bit excited about rain events, even of this minor magnitude, in September, because A, if you're a grower in the Central Valley, that can wreak havoc on your harvest. And B, if you're excited about not having wildfires in your backyard, this is a good kind of pattern to prevent that from happening, at least for a little while. This is not a pattern that is going to result in long-term end to fire season or end it early by any means, but it does mean that the risk of wildfires this week will be pretty darn low statewide. And that includes beneficial light precipitation, most likely light precipitation on the fires currently burning. So that's also beneficial. Now I'm going to switch over to the ensemble to look at the longer term pattern, as I mentioned that I like to do that. Here's this pattern right now in the next 5 days with a little bit of a trough low pressure system centered over California, this dual pair. That is out of here. In fact, this is a 5-day moving average. So let me be a little bit more specific. There we go. I was looking for the other panel here. As we go into the weekend, so we can see again that low pressure system, but pretty anomalously deep for this time of year. The second one plunges south on Thursday and then gets kicked eastward and fades away. Another ridge likely is going to build by Sunday or Monday, and it looks fairly strong, to be quite honest with you, at least according to the European model. In fact, this ridging would once again lead to quite a significant heat wave, again centered in Central and Southern California by the end of September, continuing potentially into early October. What would that look like temperature-wise, according to the European model? Well, these are some really elevated temperatures, I gotta say. So this would bring temperatures 15 to 25 degrees Fahrenheit above average, once again, to parts of interior Southern California. So I'm not convinced that heat season is over yet for Southern California, and this would be a pretty significant heat wave for all of the Southwest. Now, what's interesting is if we go over to the American model, it depicts a heat wave of significantly lesser intensity as we go toward the end of September into early October. So the large ensembles agree that conditions will trend back toward above to well above average temperatures, but the European model ensemble is depicting a stronger ridge and therefore hotter temperatures. Though usually, because they're singing roughly the same tune, it's just a difference of magnitude, I would tend to lean towards the hotter European model. And what that means is that there's a decent chance that fire weather conditions will reemerge as soon as the end of the month. So enjoy the reprieve this week, because right now there isn't much indication of a quote-unquote early autumn to come. In fact, the next thing to happen after this looks like another potentially significant heat wave in Central and Southern California. So food for thought there. All right, so I'm going to go back. I'm going to stop sharing my screen. You're going to see my face again, and we're going to answer some questions. All right. Let me just take a sip of water here for a moment. All right, the first question today, and as you can mention, this is a bit of a lower key session, although, of course, that's a good thing. It means there's nothing particularly extreme going on. Plenty of extreme things going on elsewhere in the world at the moment. Catastrophic large-scale flood event unfolding in Central Europe with record-breaking precipitation and even leading up to and including dam failures. So in the Czech Republic and Austria, some really extreme pictures coming out this evening. But that is not the focus of today's discussion. Just an illustration that often these days there's often a record-breaking precipitation or heat event going on somewhere. That's usually the case more often than not at this point. The first question is today's from Katie at Stanford, Alumni for Climate Action. Hi, Katie. Yes, I do remember our conversation, which I think is actually available on YouTube for those who are interested. I may be wrong about that, but I believe it's linked in my profile in the playlist on my public appearances playlist, so you can potentially go check that out. Katie's question is what the best forecast is for the weather in Palo Alto in the last week of October. That's reunion weekend. Well, to be quite honest with you, it's too early to say. Generally speaking, as I mentioned, actually, coincidentally, earlier in this conversation, we aren't able to give, in general, specific weather forecasts more than about 7 to 10 days in the future. And even that far out, it's a little bit fuzzy. And by fuzzy, I literally mean you should probably squint a little when you look at the maps, because the details are just not discernible that far out. But when we're talking over a month out, honestly, we can't even really do too much squinting. We can look at the seasonal outlook for California for autumn and for October specifically, which calls for an above average likelihood of warmer than average temperatures, and at this point, a slight tilt towards drier than average conditions. So I would say that the likelihood that the reunion week is either seasonably warm or somewhat even warmer than average and dry is higher than it would be in a typical year. So I suspect that's good news. But that doesn't mean that that week won't perhaps be, say, the 1 week in the fall where it rains or something. I don't see any particular reason why that would be true, but just an illustration where, for example, I can't say specifically how hot it will be that week. This is a nice illustration, but I do think it's more likely than not that it will be warmer than average and will probably, hopefully, be dry. But that's not something based on a specific weather forecast I can give this far out. It's instead just a general indication of what the seasonal models are telling us about the autumn overall, being warmer and perhaps slightly drier with a later onset to the rainy season than usual. Now, I'm saying that in a week where it is raining already in some parts of California. Not a lot, but it just goes to show you that September on the whole will end up probably as a much warmer than average month across most of the state, especially in Southern California, if you factor in the extreme heat wave they had the first couple of weeks of the month. And yet there is this nice, cool, and locally damp interlude at the moment that won't be representative of what this month will look like in retrospect at seasonal scale. So if you were just to look at the monthly statistics, you wouldn't know what happened this week. So it's a long way of saying, join me in whatever session I've got the week or so before, and then maybe we can be a little more specific. Hello to everybody. There are several folks introducing themselves. Mary mentions that the humidity was 56% and it was 20 degrees Celsius. That sounds like a pretty comfortable combination in Alameda County today. You're pointing out that it was very humid. Well, it is true that sometimes 56% humidity doesn't sound like it's very high. And of course, in winter, it would not be. So if it were 50 degrees Fahrenheit and 56% humidity, that would be an unremarkable winter condition in California. But at 20C, which I always have to do the mental conversion, I believe that's about the low to mid 70s Fahrenheit, it's going to feel pretty muggy with a 56% humidity. So the question is, and I don't know off the top of my head, what is the dew point when you have 56% humidity and 20 degree centigrade temperature? I'm not a particularly adept mental calculator, so I'll leave that math to someone else. But the question would be, what is the dew point? And I suspect the dew point will probably end up in the 60s Fahrenheit, maybe the mid to upper 60s, somewhere thereabouts. And that is well into, I guess what you could call muggy territory. So all this moisture in the air in the Bay Area didn't really rain much, but there was plenty of moisture around, and so that's being reflected as pretty muggy conditions in some spots. Similar comment, muggy and 71 degrees in San Jose. That sounds consistent. Steve has a suggestion for how to improve the workflow, and so that I don't flash everybody my full screen every time I do these. Yes, I am looking into ways. I gotta, that does require re-expanding the very limited home office space and getting a third monitor. So some capital expenditure, but the bigger challenge is space, actually. So we'll have to see how that goes. I think there may also be some software solutions where I just haven't had the time. It's been kind of an all hands on deck kind of month, season, year, decade as a climate scientist. So I promise I will get to that as the audiences for these sessions continues to grow, and I do want those connections to be more seamless. I do think on the technical side, at least, that the computer hardware is working well and that the internet connectivity is better. So those were the two primary concerns this year that I think so far are looking pretty good. Audio video is pretty good, but yes, I agree that the transitions could be improved. So that's on my list. Sean mentions, shout out from Puget Sound, similar features in Southern California to the PCCZ, so I believe that's the Puget Sound Convergence Zone. It could be, yes, essentially there's a similar coastal topographic feature up in the Pacific Northwest that results in that kind of splitting of the airflow and then the rejoining of those streamlines of the convergence of surface air up there. It can be a little more dramatic up in the Pacific Northwest because if it happens in winter under like a cold core low or something, it can actually produce convective clouds, and if the air is cold, it can actually produce convective snowfall. So there's a decent number of times when that relatively rare snowfall you see in Seattle and up between Seattle and the Canadian border is actually a result of cold air and just enough of a kick by that convergence, similar to what we saw in the satellite imagery earlier, to generate some convective showers which can fall as snow up there. Sadly, no convective snow showers in coastal Southern California, even in the coldest winters, at least not in this millennium. So you have to go up to the Pacific Northwest to that. Marty asks, what are your thoughts about the success in preventing the Davis fire from blowing up during last week's wind event? Yeah, this was an event of great concern. The Davis fire did destroy some structures up south of Reno, and it was in a pretty precarious position to potentially make a heavy run into the suburbs south and west of Reno during a major wind event last week, with gusts as high as 50, 60 miles an hour, downslope, so it would push the fire down the mountain right into the populated areas, which is the very same pattern that we've seen very destructive fires in Southern California, Northern California, Colorado, Oregon in recent years. So that is an alarming pattern from a wildland-urban interface firefighting perspective and a fire weather meteorology perspective. I think the saving grace was that firefighters had time to prepare. So the time between when the fire made its initial advance, the first day the fire was largely uncontrolled. It was just a matter of evacuating people and getting people out of harm's way. Structures did burn. There wasn't a lot of controllability. That was a wind-driven fire, but it wasn't super extreme winds. The winds were gusting 30 to 40 miles an hour, but not 50 to 60 miles an hour. Then the winds relaxed and the fire burned back upslope into heavier fuels in the trees, but not heavily wind-driven. So it became established on the upper slopes and the heavier fuels. Now, what then happened was there was a few days between when this happened, when the fire slowed down, and when the wind event occurred. And thousands of fire personnel poured in In the meantime, there was a tremendous amount of air support, helicopter water bucket drops, air tankers. They were able to put in a lot of fire retardant line between the active fire line and those neighborhoods, since they knew what direction the wind was going to be coming from. So this is a very good example of proactive measures put in place because of a good weather forecast. The weather forecast verified it really was as dry and windy as predicted, but the fire tried to poof up, and it did in a few occasions, but because the ground there was essentially saturated with ground crews, so fortunately, I mean, the fire was already close enough to neighborhoods that you could put engines in there on the ground pretty easily, and up to the point that the wind got too strong to do so, the airdrops were really effective in putting down a good line. That's pretty much what happened. It was essentially aggressive firefighting. This is one of those cases where air support was really helpful. It would not have worked had it waited until the wind had arrived. It was not particularly effective the first day of the fire. In that initial attack mode, when the fire was wind-driven, you really couldn't get ahead of the head of it. But once the weather cooperated, that air support and that ground support really kicked in, and I think that's what hemmed it in. An alternative scenario, what if the fire had started a little bit farther to the north in the place where it ended up being positioned right before that wind event did occur, but without the benefit of aggressive air support in the days leading up to it and ground crews able to both cut line and extinguish hot spots as they popped up because they were pre-positioned? I think it could have been a pretty catastrophic fire, frankly, for the southwest Reno suburbs. That fire probably would have run straight down the mountain, and there wouldn't have been a whole lot anybody could have done about it under those extreme wind conditions, because the aircraft couldn't have flown. The ground crews would not have already been in place, so they would have had to come in under emergency circumstances rapidly against the flow of people evacuating. That's that nightmare scenario we have seen play out in other places, but fortunately it didn't happen here, and I think it was partly due to luck that the initial fire in its first 24 to 36 hours did not occur under extreme wind conditions, and that it was centered where it was rather than several miles farther north. We have an analogy here in Boulder where the catastrophic Marshall Fire, which in that case did still result in a catastrophe, but in a different place and perhaps a slightly lesser one than might have unfolded, how that same fire ignited a few miles further north and immediately moved into a far more densely populated area at higher fire risk. You do think about these things, how, well, if this ignition had been just a mile or two off, or if this occurred yesterday versus tomorrow, things could have been different. And sometimes things would have been not as bad, as is the case here, sort of saved by the bell. Sometimes, they would have been much worse. So, you really don't know. And I think this is one of those cases where, arguably, folks did lose their homes, but not an extremely large number. And this could have been a mass structure loss event if it played out slightly differently, but it didn't. So, interesting, I think, lessons in the counterfactual there. That's the kind of thing that folks in the wildland fire business think about a lot, is the what ifs. What if things played out slightly differently? How can you use that as information about how to mitigate risks in the future? And I think what it continues to tell us is that wind-driven fires following exceptional periods of drought or record heat are a big problem. And if we can get a handle on those fires in the initial hours, or at least on the first day, before a big wind event, that's a huge benefit, because once those winds arrive, a lot of these fires are largely unfightable until the winds die down. That's just the nature of these events. And so I think what we're getting better at is putting out the fires that occur under the non-extreme conditions. But this gets to that point that I've talked about in other sessions, is, okay, so if we're getting really good at extinguishing fires under mild to moderate conditions, but we're not getting better necessarily at extinguishing fires under really extreme conditions, particularly extreme wind and drought conditions, the challenge then becomes, are we putting out the fires that might have offered some net benefits by buffering against the effects of the fires burning under more extreme conditions, and yet we're still seeing those fires burning under extreme conditions? So it's an interesting question, and one answer is, well, if we scaled up prescribed fire, we wouldn't have to worry so much about that. But that's a focus for a different session. Just thought it would be interesting to make that connection. This is probably a question from back when I was showing the weather model maps, but Damo asks, are the 14-day models, so the European ECMWF and American GFS, deterministic models, or do they incorporate randomness? So here's the interesting thing. The models don't need to incorporate randomness explicitly. It's an emergent property of coupled nonlinear dynamical systems as predicted by these kinds of models. This is actually one interesting thing that is different with some of these new AI, artificial intelligence, machine learning based models, is some of them do not exhibit the same degree of randomness. And that might sound like a good thing, but the thing is that randomness is real. It actually exists in the real world, and the reason for it is essentially the butterfly effect. That's not just a fancy term. That's a very real process that is quite relevant to weather prediction, among other prediction type problems in the physical Earth system. And the answer is that there is a theoretical limit to predictability even if you have a perfect model, because infinitesimally small perturbations to the initial conditions, which of course we can't measure. The weather model doesn't know, if I sneeze in the next 30 seconds, for example, outside, the weather model doesn't know whether or not that happened. And it might seem ridiculous to assume that that would propagate to affecting solutions at larger timescales. And in that case, perhaps it really doesn't matter. There is a spatial and timescale below which things sort of get lost in the noise, but not always. And sometimes that little initial perturbation at small scales can cascade upward to have a much larger effect. That's literally the somewhat tongue-in-cheek original formulation of the I believe it was a talk title by Lorenz, is if a butterfly flaps its wings in Brazil, does it trigger a tornado in Texas? It's something close to that. The funny thing is, he originally intended that, by the way, to have an obvious answer of no, but to be provocative in a way that caused people to ask deeper questions about this. But the interesting thing is, in a trivial sense, the answer is no, because you would never be able to tell. And in any meaningful sense, it didn't cause the tornado. But the interesting question is, can really tiny perturbations cascade upward in the system in completely unpredictable ways to influence large-scale weather patterns, the existence of a hurricane or not, for example? Something as dramatic as that, or a blizzard in location A versus a heat wave in location B. And the answer is yes. The reason why that matters is that both of these models are inherently deterministic. So how can that be then? How do we have any predictions after 14 days? Well, the way we do it is you run the deterministic model that essentially doesn't need to explicitly incorporate randomness because it's an emergent property of the underlying physics, but we run the model dozens of times. It's the same computer model, but we run it with slightly different sets of initial conditions because, of course, can you tell me exactly what the air temperature is over a remote patch of the Southwest Pacific Ocean right now? No, and I can't tell you what that is either. Nobody can. So because we don't know the initial conditions of the weather perfectly, we have to make a best guess as to what they'll be. And there's 100% of the time it's wrong, right? There's always some error because we don't have temperature sensors blanketing the surface of the Earth. We don't have humidity sensors all through up and down the troposphere, up 30,000 feet at every point on Earth. So everything is always an interpolated estimate, best guess, with uncertainty. So the way we run these ensembles is to use the very same deterministic model that's subject to all the uncertainties of that butterfly effect. But we run it a bunch of different times, usually dozens of different times, 4 times per day, using not only the best guess of what those initial conditions are, but also perturbations surrounding that best guess, equally likely possible presence, meaning that we don't know exactly what the weather is at all points on Earth right now. So instead of just giving the model our best guess, we give the model our best guess plus a few other best guesses of what it could be, assuming a certain amount of error. So add some noise to the temperature, add some noise to the wind field within the range of uncertainty that we know exists. And in doing so, now we have a plume of independent deterministic model simulations, but dozens of them. And that is what the ensemble is. It's somewhere between 2 and 4 dozen individual deterministic model predictions, hopefully under most cases, they don't vary dramatically from one another, but sometimes they do. Sometimes you run the exact same weather model 40 times using roughly the same initial conditions, but with some slight error intentionally introduced, and you can get 30 model members that show a hurricane and 10 that don't, or 4 members that produce a blizzard and another 11 that produce a heat wave and another one that produces just a regular old rainstorm. Sometimes the departures are that dramatic, or in California's case, the ensemble might say there's one member, there's always one member of the GFS that's doing something wild and crazy. One of them might produce a 50-inch rainstorm in California. 12 of them might be completely dry, and then the other 30 or so produce a reasonably strong winter storm. The idea being that the most likely outcome is a moderate winter storm, but it also might be completely dry, and if we're really unlucky, the arc storm is coming with that 50-inch rainfall. And from the initial point in time, technically, each of those outcomes is possible, but they're not equally likely. If one member out of 40 or 50 says, the biblical storm is coming, maybe there's like a 1 or 2% chance of that happening. But if then 30 of the members say a moderate rainstorm, okay, well then 30 out of 50, that's more likely than not what's going to happen. That's sort of how to interpret the ensembles. They're not perfect, and sometimes they're known as they exhibit under-dispersiveness, meaning that they don't capture the full range of possible outcomes. They're too narrowly clustered, and sometimes they're over-dispersed. Sometimes they just are all over the map. Interesting case of a metastable bifurcated process, but anyway, that's getting into the nonlinear dynamics of the system more than I wanted to today. But it's a really interesting question, and it really boils, when you get down to it, it has very practical implications. It is the reason why I can't give a specific weather prediction for the last week in October, but why we can say something probabilistically that October is likely to be a warmer than average month in California, even though there could be a week in there that's cool and rainy. But then the other 3 weeks would then have to be the warm ones and the dry ones to balance that out. It also means that there's a limit in utility to those seasonal outlooks because they don't tell you everything you need to know. In this case, if you really want to know if it's going to rain that week in October, I can't tell you that right now. But if you're thinking about, say, wildfire risk planning, which is something we've talked about recently, the tilt towards much warmer than average and perhaps drier than average does tell us something about the relative level of preparedness that is wise, and that fire season probably isn't over yet. So it can tell us different things about different contexts, essentially. Comment from Mary that the storm Boris is warming slightly. Yes, in Europe, by the way, they name non-tropical storms, which I have mixed feelings about. All right, I'm getting, by the way, an error message from YouTube that man, I really jinxed it earlier when I said the connection was good. It's telling me that there is not enough bandwidth to maintain smooth streaming. Curious if anybody has noticed any buffering or lags or jumpiness, or maybe this is just a premature warning. Anyway, let me know. Yes, Storm Boris is the one I mentioned in Central Europe that's causing the catastrophic flooding. Or he mentions it's warming and might drift over the Alps with more snow and potential flooding from that melting. That would be perhaps an even greater disaster. I have not been paying that much attention to it, but that would be interesting to take a look at. It is equivalent. It is sort of an arc storm-like scenario for Central Europe. This is the kind of event that we've been talking about for a long time in California, and we've now seen it unfold in different parts of the world, a similarly extreme large-scale event. And that is the scale of what's happening right now in that part of the world. The question about above or below average offshore wind activity in California this fall. Frankly, I don't think we have much predictability of seasonal scale winds. So now, is the likelihood of offshore wind occurring coinciding with unusually warm and dry conditions higher than usual? I think the answer is yes, especially in Southern California, just given the antecedent dryness and the expectation of a late start to the rainy season with high temperatures. So that is that co-occurrence question, I think, is easier to answer than the question about the winds themselves. Yeah, there's a few comments about how areas up in northeastern California and northwestern Nevada, there's an expanding wildland urban interface, and it's true. There's more and more people moving into high-risk fire zones than ever before, so we are going to see more fire events like this one. No question about that. All right. Well, I'm actually getting another YouTube error here, although folks are reporting no problems, so I may have to look into this a little bit further on my end. It's only in the last 2 or 3 minutes that it's saying there have been some issues, so I will try and take a look at that. But I think I have made it through most of the questions today, and hopefully, okay. So now folks are saying they're seeing some issues. Okay, well, I'm going to take this as a sign to call it a session. Fortunately, this time I did make it all the way through what I wanted to talk about today. Got to get back on the phone again with Xfinity. Always a good time. All right, folks. Well, thanks for joining. And I'll probably have a session later next week to coincide with that warming trend I mentioned earlier. And a potential return, potentially, to fire weather eventually, too, by the end of the month. All right, folks. Thanks for joining, and see you next time.